Okay, lesson 9.2 is on quadratic functions. And this is kind of a continuation of lesson 9.1. You will be graphing quadratic functions. Only today you're going to look at quadratic functions of the form ax squared plus bx plus c. So what's different from lesson 9.1 is we're going to add in this middle term. So if you're making yourself some Cornell note paper, make sure you write in. This is lesson 9.2. Put in your essential question based on this learning target. Hit the pause button, and when you're ready to go, hit the play button. Okay, you remember that the standard form of a quadratic equation is y equals ax squared plus bx plus c. And a and b and c are all numbers. So if I give you an example like y equals x squared minus 6x plus 4, you can identify the a, b, and the c. Notice in this equation, there is no number before the x squared, so you just assume that it's a 1. So if I asked you what's a, b, and c, you should be able to identify that a is 1, b is negative 6, make sure you include the negative, and c is positive 4. That's going to be important that you know that, because on today's lesson you'll be using the values a, b, and c to help you graph a quadratic function. Again, this is review, but remember we graphed some parabolas, and they're curves. And the thing that you're supposed to remember about a parabola is that it's symmetrical, and it has a line of symmetry, or what we refer to as the axis of symmetry. And the axis of symmetry just cuts the parabola in half and creates mirror images. The left side is a mirror image of the right side. This is important because you're going to use a formula that will tell you exactly what the axis of symmetry is. So the first thing that you should be writing in your notes is the axis of symmetry formula, which is x equals negative b over 2a. The b and the a come directly from the equation back here. A, b, and c, of those three values, the axis of symmetry is negative b over 2a. Okay, that was kind of quick. Let's go ahead and do the first example problem. What you should write down right now in your notes is problem 1 and this equation, y equals x squared minus 6x plus 4. I'm going to give you 5 steps that will help you graph a parabola when you're given a quadratic function. Now notice we're not using a t-table because the equations you're going to see today are a little more complicated than the ones that you saw in the last lesson. So here we go. First step is to find the axis of symmetry. And now let me back up. In order to find the axis of symmetry, you're going to need some values. So the actual first step would be to write out what a, b, and c are from the equation. So from this equation, a is 1, b is negative 6, and c is 4. Now, first thing you're going to do after that is find the axis of symmetry. And the axis of symmetry is given by the formula that you just wrote down. X equals negative b over 2a. So step 1 is to write x equals negative b. Now in this case b is negative 6, so negative b would be negative 6 or positive 6 over 2 times a. 2, and in this case a is 1. So the axis of symmetry is 6 over 2, which equals 3. The axis of symmetry is just a line that splits the parabola in half. So the line x equals 3 on the graph is at 1, 2, 3. X equals 3. That's the axis of symmetry. That means your parabola could look like this, could look like this, could look like this, but it's going to be somewhere where the axis of symmetry is at x equals 3. Alright, step 2 is to find the vertex. Remember, the vertex is the point either at the top of a parabola or at the bottom of a parabola. And the vertex is always given as a set of coordinates that is an x and a y. Well, the vertex will always be on the axis of symmetry. So if you know the axis of symmetry is at x equals 3, then this is half of your vertex. That's the x value. One more time, if you know the vertex is on the axis of symmetry, then the x coordinate is going to be whatever number this equation is. To figure out what the y coordinate is, you're going to take the value for x and you're going to put it into the equation y equals to figure out what y equals. So I'm going to write y equals, my equation is x squared, so I'm going to replace x with 3, that's 3 squared, minus 6 times 3 plus 4. 3 squared is 9, minus 6 times 3 is 18, plus 4. 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. So the y-coordinate for the vertex of the parabola is negative 5. Now I can put that point on my graph. I'm going to go over 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. There's my vertex. One more time. I'm looking for a parabola. It could look like this, or it could look like this. But now I know the line of symmetry or axis of symmetry, and I know the vertex. The third step is to figure out, does the parabola open up or does the parabola open down? Remember, an open up is a smiley face, and an open down is a frowny face. To determine whether or not the parabola opens up or down, you just have to find the sign of the x squared term. If the sign is positive, then it's smiley, and if it's negative, it's frowny. So looking at the original equation, here's the x squared term. Is that a positive x squared term or a negative x squared term? Well, 1 is positive, so it opens up. So now I know my parabola is going to open up like this. But I don't know if it opens up like this or like this. I don't know the shape, I just know now the axis of symmetry, the vertex, and which way it opens. So the last two steps involve finding actual points on the parabola so I can make an accurate graph. So step 4 is to find 2 other points on the parabola. I have 1, that's the vertex. Now I'm just going to find 2 others. Well, I can find 2 other points kind of like a t-table by selecting values for x. Simple values for x. So if I choose x equals 0, that means I'm going to take 0 and put that value up into the equation, the original equation, and figure out what the y coordinate is. So y equals 1 times, replace x with 0, minus 6 times 0, plus 4. 0 squared is 0, times 1 is 0, minus 6 times 0 is 0. I'm left with 4. So one other point on the parabola is 0, 4. So I go to my graph, and I graph 0, 1, 2, 3, 4. 0 in general is the easiest point to choose. Then I'm going to choose another point, x equals 1. And I'm going to take that point and put x back into the equation. So I've got y equals 1 times 1 squared minus 6 times 1 plus 4. 1 squared is 1. 6 times 1 is 6 plus 4. 1 minus 6 is negative 5 plus 4 is negative 1. So my second set of coordinates is 1, negative 1. So I go back to my graph, I go over 1 and down 1. So I have 3 points. One of them is on the axis of symmetry. 2 of them are on the left-hand side. Now if this shape is symmetrical, then the last step is just to find the reflection of the 2 points that you calculated. So this point right here is 1, 2 away from the axis of symmetry, so I'm going to reflect it over to the other side and go 1, 2. And the second point right here is 1, 2, 3 away, so I'm going to go 1, 2, 3 over this way. Now I drew those so you could see how I was finding them, but you probably shouldn't draw them when you're graphing your parabola. Now that you've got those points, you can connect the dots and try to draw a good curve. And that's the graph of this parabola, y equals 1x squared minus 6x plus 4. Quick review. When you have an equation, first figure out what the a, b, and c are. Step 1 after that is to find the axis of symmetry by using the formula. Step 2, use the x value that you get, put it into the equation to figure out what y is, so that you can find the vertex. The third step, figure out whether the parabola opens up or opens down by looking at the value of a. The value of a. Once you know whether it opens up or down, then you can find 2 other points that will be on the parabola. Good values to choose are 0 and 1, but it depends on where your vertex is. Once you find the 2 points, reflect those across the axis of symmetry, and you have the graph. It's a lot of work. It's a lot of steps. And we're going to do this in this lesson, and then we'll eventually move toward using the graphing calculator. So, let's try another one. Graph the function y equals negative x squared plus 4x minus 2. You should hit the pause button and go through each of the steps. I'll get you started though to remind you. This is the axis. X equals negative b over 2a. Step 2 is the vertex. Step 3 is up or down. Step 4 is find 2 points. And step 5 is to reflect those points. Okay, go ahead and pause. Try this on your own, and then when you come back, I will finish it for you. Alright, before I get started, I am going to identify what a and b and c are in this equation. A, because there's a negative here, is negative 1. B is 4. And c is negative 2. So step 1 is to find the axis of symmetry. And I'm going to go ahead and erase this so I can have more room. The axis of symmetry is given by the equation negative b over 2a. So if I put b in place of b, I get negative 4 over 2 times negative 1. Negative 4 over negative 2 equals 2. So the axis of symmetry is x equals 2. Now my suggestion to you is that as you find each piece, as you do each of these steps, that you go immediately to the graph and add that to your graph so that you don't get lost. So the first step is to find the axis of symmetry. I found it. It is at x equals 2. So I'm going to draw the line x equals 2. The next step is to find the vertex. The vertex is an x and a y coordinate. You already know half of the answer because you did step 1. The x coordinate is 2. You just have to find the y coordinate. And you find the y coordinate by taking the value of x and putting it into your equation. Y equals, in place of x, I'm going to put 2. And remember, whenever you replace a letter with a number, you put it in parentheses. Plus 4 times 2 minus 2. 2 squared is 4, and then you put the negative on there. Negative 4. Plus 4 times 2 is 8, minus 2. Negative 4 plus 8 minus 2 equals 2. And that's your y coordinate. So now you know the vertex is 2, 2, so I'm going to go right to my graph and graph it. 1, 2, 1, 2. There's my vertex. Step 3 is to figure out whether the parabola opens up or opens down. You can tell whether it opens up by looking at what a equals. If a is positive, then it's a happy parabola, it opens up. If a is negative, then it's a sad parabola, it opens down. In this case, a is negative, so my parabola is going to open down. But I can't draw that yet because I don't know exactly what it's going to look like. I just know when I'm done it should be a frowny face. The fourth step is to pick 2 points. So I look at my picture. I'm picking 2 points other than the point that I already know, which is the vertex. So if I pick x is 0 and x is 1, that's 2 points that I don't already know. So I'm going to let x equal 0 and x equal 1. And what do I do with those values? I put them back into the equation y equals negative x squared plus 4x minus 2. Y equals negative x squared minus 4x minus 2. 0 squared is 0. 4 times 0 is 0. All that's left is negative 2. So one of my coordinates is 0, negative 2. So I go to 0 and go down negative 2. Then I'm going to do the same thing with x equals 1. I put 1 in place of x. So I get y equals negative 1 squared minus 4 times 1 minus 2. One squared is 1. This is actually plus 4 times 1 minus 2. Negative 1 plus 4 minus 2 equals positive 1. So the second point I have is 1, 1. Last step, take those points and reflect it. This red dot is 1 away from the axis of symmetry, so I go 1 on the other side. This green dot is 2 away from the axis of symmetry, 1, 2, so I go 2 on the other side. So when I'm all done, I get a parabola that curves down this way and curves down this way. It's a frowny face like I said it was going to be. It has a vertex at 2, 2, following the axis of symmetry, which is x equals 2. And that's it.